In this video, we're going to be applying everything we learned in the previous section into word problems. Okay, so I know when we open up an assignment, there's word problems, we start freaking out, but it's okay. It's going to be very important that you read the problem thoroughly, and then that's going to help you set up the equations and then solve them just like we already know how to solve them. So on this one, we're just actually going to jump straight to the examples we're going to be working on. So this is what the problems are going to look like. You're going to have a situation, a scenario where there's two different variables that you're going to have to identify first and then set up your equations, okay? So first thing we're going to do is just read the problem. So here we have a scenario, right? We have the admission fee at an amusement park is $1.5 for children and $4 for adults. On a certain day, 293 people entered the park, and the admissions fees collected totaled $802. How many children and how many adults were admitted? So again, these are kind of like little puzzles. First thing we're going to do is create a system of equations. Before you do that, though, you do have to identify your variables. If you remember the previous video, we do have to identify what is going to represent what. And we normally use X and Y. So this is what we're going to do. There's two things that that are happening in this scenario. We have children and we have adults. So there we go. We're going to have X and Y represent those. It doesn't matter which one represents which. Just remember that what you stated at the beginning. So in my example, I'm going to let X represent the children's tickets and I'm going to let Y represent the adult tickets. Again, you could do it vice versa. But just at the end of the day, remember what you had said originally. So X represents children, Y represents adults. Now, what we're going to do is use the information that they gave us to come up with our equations. So first thing we're going to do is just talk about tickets in general. How many tickets did they receive in total? So let me just go ahead and read the problem real quick. This talks about money, so I'm not going to talk about that yet. This one also talks about money. Here we go. On a certain date, 293 people entered the park. So hopefully you agree with me that the first equation is just going to be X plus Y equals 293 because I know that the children's tickets plus the adult tickets has to give me 293. So there we go. That's going to be my first equation. Now my second equation is actually going to be talking about the money. So here we go. First one, like I said, X plus Y equals 293. But now the second equation is going to be the one where I'm going to be throwing the money that they gave me. So $1.5 for children. So that's going to go in front of the X because X represents children. So 1.5 for every child ticket. So I'm going to multiply them. And then I add it times the $4 that every adult ticket is worth. And since Y represents adults, I'm going to put 4Y. When I add all of those tickets with their monetary value, I'm supposed to get the $802 that they collected at the end of the day. So just in general, for all these types of problems, you're always going to have two equations. One equation where you just talk about the amount of tickets, and then the bottom one is the one where you deal with the money. So you put the money for each ticket and then the money in total. Okay, so look at that. All you had to do was just kind of dissect the problem and then create our equations that we're going to be working with from now on. So actually from here and on, I don't care about the problem anymore. I already have my equations, so then I could solve them. So this is what we're going to do now. We're just going to look at those. Now, just as a reminder and overemphasizing everything that I've said up to this point, you guys can solve whatever method you prefer. Now, for this one, I'm going to solve by substitution. So let's solve this one by substitution, but again, you can use whatever method you like. If you want to solve by graphing, if you want to solve by the elimination addition method, go for it. Okay, so let's just practice. Let's do this one using the substitution method. So what I'm going to do is that I'm going to grab the top equation and I'm going to solve for Y just because. You could also grab the top one and solve for X. That's perfectly fine. But I just solved for Y just because that's what I felt like doing. So I'm going to solve this one for Y. I'm going to throw the X to the other side. So I end up with Y equals 293 minus X. And then if you remember from the substitution method, now what I do is that I replace that into the other equation. So since this is equal to Y, I'm going to replace it right there on the Y of the second equation. So I substitute, I'm going to have 1.5x plus 4 instead of the Y, 293 minus x in parentheses equals 802. And then once I substitute, I just solve. So 4 times 293 gives me 1,172. And then 4 times negative x gives me negative 4x. Now we combine like terms, so 1.5, and you guys don't, it's okay, trust me, you're going to be fine. 1.5x minus 4x, I put that in my calculator if I'm not sure, and it gives me negative 2.5x. Now this one doesn't have an x, so I'm going to throw the 172 to the, oh my goodness, to the other side, and it becomes a negative 1,172. The negative 2.5 obviously stays on that side. It's still negative. In my calculator, I put 802 minus the 1,172, and I get negative 370. And again, don't freak out. It's okay. The last thing we do here is that we divide both sides by negative 2.5. You always divide by whatever is in front of the x. So once I divide by negative 2.5 both sides, I get that x equals 148. Now, before you keep on going, because obviously we're not done with the problem yet, just make sure your answer makes sense. In this problem, x represents the amount of tickets that we sold for children. So if this answer would have had a decimal, then I would start freaking out because we cannot have like 148.5 of a child in our amusement park. That would be really freaky. So it has to be a whole number, which it is. So then we proceed. Again, if there's a decimal, if there's a fraction, then stop what you're doing and go back and make sure we did everything correctly, because maybe there was like a little mistake in there. But this one makes sense. Obviously, we're not done. Now we have to figure out why. So I know that x is 148, so I'm going to substitute the x into whichever one of these equations you want to find y. Obviously, hopefully you agree with me that this is a much prettier equation to play with than the bottom one. So I'm going to play with that one. Instead of the x, I'm going to replace the 148 that I found out earlier. And then I just solve. So if I want to solve for y, I'm going to throw the 148 to the other side, and it becomes a negative 148. And then in your calculator, you could just put 293 minus 148, and you're going to get that y equals 145. Of course, I know you're like so tired, but we're not done yet. The last thing we have to do is just make sense of our numbers. I know that x is 148. I know that y is 145, but what does that mean? So I'm just going to go quickly back to the first slide where we had talked about. And remember, this is very important. Now you have to go back and remember what was x and what is y. X represents the children's tickets and y represents the adult tickets. So now I can understand what my answers mean. So now I know that the 148 represents the amount of children tickets that we sold, and the 145 represents the adult tickets. Again, just to make sure, you can always double check your answer. If you add those two together, you're going to get that it's 293 in total. And then if you multiply each ticket by the price and add them, you're going to see that it adds up to the $802. So there you go. I hope you guys like this one. It wasn't that terrible. All right, we're going to do two more problems. So here we go. Next one, let me just go ahead and start by reading it, right? So we have here a man has 200, oh my goodness, not 200. A man has 24 coins in his pocket, all of which are dimes and quarters. If the total value of his change is 450 cents, how many dimes and how many quarters does he have? So this one, again, they're little brain teasers, so really fun to do. And then we just set it up. So again, system of equations, we have to have two equations. Just like we did with the tickets, we need one equation just representing the amount of coins. And then the second equation is actually going to represent the money or the monetary value. So we know that the man has 24 coins in total. But before we do anything, we need to set up our variables. In this one of the variables has to represent dimes. The other variable has to represent quarters. So I'm going to let x represent dimes and y represent quarters. Again, you could do it backwards. It's fine. Now, here we go. Let's set up our equations. The first equation has to do just with the amount of coins. No money, just the coins. So the number of dimes and the number of quarters has to add up to 24 coins. So there we go. That's going to be my first equation. X plus y is just 24. Now, in the second equation, that's the one where we deal with the value, the cost of the ticket, the value of the coin. So on this one, they don't tell you, but hopefully you know, right? Dimes are the ones that are worth 10 cents. So 10 times x plus the quarters, which is my y, are 25 cents each, right? So 25y. And when I add them, they have to give me the 450 cents that the man says that he has on his pocket. So there we go. Now, since the 450 cents are just cents, that's why I didn't put any decimals. So don't worry about putting the 0.25 because it's 25 cents. Don't worry about that. So as we're just dealing about cents with no decimals, we just put it like that. And just like we did on the other one, I don't care about the problem anymore. I have my two equations. So now I just solve these two. Just since we did the first one using the substitution method, just for practice, I'm going to do this one using the elimination method. Again, you can use whatever method you prefer. If I want to solve this problem by using the elimination method, remember elimination method is when both of the equations have different coefficients. So in order for the top one to cancel with the bottom one, I need a negative 10 here because the bottom one has a positive 10. So if I have a negative 10 here, they're going to cancel out. But since I have to multiply the top one by negative 10, I have to do it to everything, okay? So negative 10 times x gives me the negative 10x that I wanted. Negative 10 times y gives me negative 10y. And negative 10 times 24 gives me negative 240. And then look at that, the x's are opposites now, so they cancel out. Again, remember the elimination method is called the addition method as well because we have to add the equations. So once I add them, the x's cancel out. 25y minus 10y or negative 10y plus 25, doesn't matter the way you do it, gives me 15y. And then negative 240 plus 450 gives me 210. Now from here, I just have one variable to deal with. So the y, to get rid of it or to leave it by itself, I'm going to divide both sides by 15. And then I'm left with 210 divided by 15 equals 14. Now again, make sense of the question before you move on. Since we're talking about coins, it has to be a whole number, 14 coins. Again, if this would have been 14.5 coins, then something's wrong and we will have to go back and check our work. But there we go. We already know that we have 14. Now we're not done. We have to find the value of x. So y is 14. So I'm going to use whichever one of these equations that you want. Again, choose the easiest one. That one looks pretty simple. So I'm going to use that equation. I know that y is 14. So I replace it with a 14 and then I just solve. So I throw this 14 to the other side and I'm left with x equals 24 minus 14. That's a subtraction sign, believe it or not. And then 24 minus 14 gives me 10. And that's it. We're done. Just make sense of the numbers that you got. X equals 10. If you go back to a previous slide, you remember that I said that X was going to represent my dimes. So that means that I have, or that the man has 10 dimes and 14 quarters. So I'm pretty sure you're having fun, right? These are pretty neat. Okay, let's go ahead and try one last example. So in this example, look at that beautiful cow. We're talking about an animal farm, right? So here we have an animal farm, and for some reason, the guy in charge of the farm, right, he has chickens and cows. Now, for some reason, he was bored and he counted that there's 55 heads in total, and there's a total of 150 legs. Now, the question is, how many chickens and how many cows are on the farm? Like individually. We know there's 55 in total, but how many are chickens and how many are cows? So this is really fun. So again, before you do any problem, you do have to set it up and you have to let me know what represents what. So again, we're using X and Y. You guys can use whatever letters you want. If you want the H to represent chickens and the C to represent cows, go for it. But I always use X and Y. So I'm going to let X represent the number of chickens and Y represent the number of cows. And then we'll just set up the problem. So first problem, just like any other problem, the first equation has to represent the total. So I know that my X plus Y is going to add up to the 55 heads, right? Because that is another way of saying that there's 55 animals, because every animal has one head. Hopefully you knew that. So X plus Y is going to be 55 because that's the amount of heads or the amount of animals. And then the other equation is going to come from this really weird thing that he told us, right? We know that there's 150 legs. So here's where you have to have some sort of like animal expertise or animal knowledge, right? So hopefully you know that chickens only have 2 legs, right? Like 2 little legs, whatever they're called. So that's why I put 2x because the x represents chicken. So each chicken has 2 legs, so 2 times x. And then the cows have a total of 4 legs. So 4 times y because y represents cows. And when I add all of those legs, they're going to add up to 150. Okay, so that my second equation represents the amount of legs. So we have an equation for heads, we have an equation for legs, so now we can move on. Okay, so again, I don't care about the problem anymore. I have my equations, and then we're going to solve them. Again, you could use substitution, you can use graphing, or you could use elimination. Like I already told you, I love elimination, so I'm just going to go for it. But again, you can use substitution. So if I want to eliminate these, again, you can eliminate the y's, but I'm just going to eliminate the x. I need a -2 here so that it eliminates with a +2. So I'm going to have to multiply all of the top by -2. Now again, it's all of it. So -2 times x gives me -2x, -2 times y gives me the -2y, and the -2 times 55 gives me -110. If you notice, now both of these are opposites, so I can move on to adding them. So when I add them together, these two cancel out. The 4y minus 2y gives me +2y, and -110 plus 150 gives me 40. Now, to leave the y by itself, I divide both sides by 2, and I'm left with y equals 20. Okay, again, since we're talking about live animals, it had to be a whole number. I don't want 20.7th of a cow. It has to be a whole number. So y equals 20. Now, of course, I have to go back and figure out what is x. So I go back. You can use whatever equation you want. Use the easiest one, which is what I always recommend. So we use that one. I know that y is 20. So the y is replaced with a 20. And then I just solve. So x plus 20 equals 55. I move the 20 to the other side. It becomes a -20. And then, sorry, I put it twice, but this becomes a -20, and then you could just figure it out. 55 minus 20 is 35. So my x equals 35. Again, you are not done until you can translate this back into the application. So since x equals 35, that means that my animal farm has 35 chickens and 20 cows. So I'm hoping you guys had fun with these. I did. If you didn't, I'm at least hoping you understood them. But if you didn't, just make sure you let me know and we could review a little bit more of these.